programming engineers. Welcome back once more to this course for frequency variators or drives. So today I'm going to be showing you how a drive works. So I'm going to explain to you in a way that is going to be very, very easy. A couple of days ago, I had a meeting with an engineer. He's actually a student. And we even, we became friends of it. He's over at Brazil, Engineer Gonzalo, big hug for you, where he had explained that he had many problems with understanding the drives concept.
And that basically where he's located, this is an everyday issue. Okay. They actually he had some concepts that were mixed up because of the same thing. And his company, or at least the company that he worked with, they had already paid for course drives or drive courses. But he was getting oversaturated with information on how it actually worked. So then, I'm going to explain to you guys the same way that I explained it to you guys. Because
it really took me less than 5 minutes to help him understand these concepts. And also very quickly. So, and he said, you know what, thank you very much for the way that you explained this to me. Because now all the concepts are very, very clear. So I'm going to do this pretty summarized. I'm going to do this summarized version and the on the field version. Okay? So let's begin. First off, I had told you about the speed formula. I had previously told you about this formula so that you guys could see that really by changing the frequency, we would be able to change the speed for our motor, which is what we really want to control. Okay? But there's a problem here with this formula. This formula right here works incredible. It works spectacularly even. It's one of the simplest formulas to know the speed of a motor. But generally, this frequency is fixed. Now, how do I know this? I'm sure you guys already did this. Because F, which is frequency that we get in hertz, this is fixed because they say, well, in Europe, if you use 50 hertz, then what's going to happen here is you're going to get these RPMs. And so depending on what's going to vary here, it depends on the pulse that you use. So then you're going to get these results. And the only thing that's going to change is actually the polarization number, the pulse number. Now, why is it fixed? Because actually, as I had previously told you, each country has its own fixed frequency. Now, this depends on each country, but they already have their frequency established. Okay, so let's go back. And so therefore, this brief diagram, this small diagram with its image, is the easiest way to know what we need in general, so that our motor can be connected, and that way we can use our drive. Okay? Now, how does the drive work? In this case, this is a drive input, a mono drive input. So it's asking us for a voltage, yes, a 220 volt, but mono-phased, single-phased. Okay? Now, we have here our neutral and our line. Okay? So this is our input, our feed. And here we have some terminals for our drive. We have a lid here, which very shortly we're going to verify this with me. So each one of the drives that we're analyzing for all different brands, you will notice that they're basically very similar. Okay? All right, so then we have our terminals, we have our inputs, and we have our outputs. Now, those outputs are going to go directly to our motor terminals. Okay, we have here our lid. We remove this, and we are going to have our connection terminal, or the borns. So here we have our delta connection. And if you guys remember, this is all in vertical. Let's just do a double check, just so you guys can see that it all makes sense. Okay, so we go back. And from here, we're going to start running our cable to our borns, our terminal. That's it. Okay, there's really not much more that we can do. So then here, we're going to have now a tri-phased one. So this one is mono, single-phased. Okay, now we also have something else that I hadn't showed you, which is the brake resistance. Don't pay much attention to that because this is optional, guys. Okay? Generally, the way that this works is that this works for the applications where they are vertical. Okay? Or when they have more inertia when they brake. So when it brakes unexpectedly, that uses a very high temperature. And there's also an over voltage. And that over voltage is the one that we need to store somewhere, someplace. So somewhere, this is the brake resistance, depending on its application. So we're going to look into this future in the short future. Now, this is a must, which is voltage, its feed, which is the RST, or line 1, line 2, and line 3. And from here, it goes through all the voltage conversion. And then in the end, we're going to get the final voltage, the end voltage that we're going to connect to our motor. Okay, whether it's single-phased or tri-phased, it's going to be this way. And here, obviously, we have its ground connection. Okay? Now, you guys tell me, or you guys might say, where can I really modify the frequency if frequency cannot be modified? This is where we have our map for different regions all across the world, where I am really literally explaining this. So if I modify directly on my motor, if I modify its frequency, but directly to its input, then that way I would be able to modify its speed. I mean, without the need of a drive. But remember that this voltage is being supplied by our government, or depending on where you're located at. But this is a same or an equal all over frequency. If my supplier says, I'm going to give you 127 volts, We're not going to have, there's no other option. I have to take that 127 speed. So obviously, they can give me some sort of special situation, and maybe they can say directly from my electrical provider or supplier, whoever manages that part, I can say, well, you know what? I want my plant to generate between 220 volts and 240 volts. Okay? And that is going to be supplied. Everything related to cables, transformers, etc. So that way I can connect my devices to that voltage. However, careful with this, guys, because if once I connect my machines and everything else that I need, but the frequency is exactly the same, then on the feed part, the frequency is going to be the same thing depending on the country where we are located in. Which in this case, I'm in Mexico. And from what I gather, in Latin America, voltage is 100 to 127 volts. So if we want something additional, we need to talk to our electrical supplier. But it's not something that they can give us where they can say, you know what, sir, I'm going to give you this device which is going to help you modify your frequency. Unfortunately, it doesn't work like that. So those 60 hertz is going to be affected by the rest of the country. So them, as electrical suppliers, what good is it for them to give us a machine or a device to modify that frequency? Because it's for everyone. This is why I'm telling you that the input does not modify the frequency. That is going to be a given from our electrical supplier in our country. Okay? So how do we really change that frequency? This is where we actually, this is the fun part related to drives. Because what we say is whatever is physical cannot be modified. The laws of physics cannot be modified. However, we can lie or simulate a physical effect, which in this case is going to be something electric. But why, you ask? You see, frequency, its unit of measurement is hertz, or R hertz. So if we take a frequency reader and we measure the frequency directly to its AC, whatever we have here in our house or our industry or our company, we're going to notice that it is a pretty big oscillating range. It varies a lot. So remember that on our hertz part, these go, as I said, in waves. So 1 hertz, a hertz equals to a positive change, and then it has to go downwards to make it a negative. Okay, so this is a full wave related to time. So therefore, a hertz or a hertz runs with 1 cycle. Okay? I have to do this 60 times, however, in 1 second. Now, this wave change is what is actually going to make my motor be either quicker or make it faster. Okay? While I have more hertz, then my motor speed is going to be quicker. Remember this. The more amount of hertz I have, the more speed I'm going to have in my motor. However, the less hertz I have, the slower the motor is going to be. Okay? Now, this is for a single-phased motor. Okay? If I only use one and it's neutral, it's not really going to matter. Because in the end result is going to be the same thing, a wave. However, when I combine three phases, if you can see here, it's already graphed, then the waves are going to start separating by 120 degrees. Now, a variator can work either with a single-phased feed or a tri-phased feed. But which one is more efficient? A tri-phased is more efficient because it allows you to use a more constant voltage. So if you notice here, if it were single-phased and we follow our black line, remember guys, that this goes according to time and goes hand in hand with voltage. Okay? Now, if you notice, once we try to create a different wave, which is going to be on this side, this is a big gap. But what's the advantage of having less separation, which in this case, our phases are what are going to assign our separation. So the bigger the separation means that there's going to be more torque. So it can be exactly the same thing. However, it's going to be a bigger pair. So something else that you guys should learn, and I'm going to leave this as an extra additional lesson. The more phases you have in your induction motor, then the more torque are we going to have in our motor. Okay, now, this is how frequency works. Okay, whatever we want to modulate or module is this. But I had told you it's basically impossible because of the political aspect of what energy is at a global scale, okay? Or at a regional scale. Just because they can't move their frequency independent. They can't be independent on each one of the installments. Okay? So, for this, check this out, guys. Our drive is divided in three parts. The verifier, the direct air film, and the inverter part. Now, what does this do? What is it that we need? In a variator, all that we need is, all right, so let's say we can't modify our speed or our input voltage, okay? That is already set. We can modify the current as well as we can modify the frequency. But this drive frequency actually works so that from there we can enter that frequency and that voltage. And for the output, that is going to be what we are going to be able to do and to run and to modify. So basically what we're going to have to do is amplify or decrease our frequency. So basically what helps us is to take our speed or show that voltage or take that voltage and be able to modify it directly. So that now we can control that frequency or that speed. So that's what the drive is for. The rectifier part, I like this. Or at least I like that we are associating with different devices. Okay? So the rectifying part is where we can find the diodes. Why the diodes? Because we can turn from the energy from AC and we wish to change it to DC. Okay? Now, how does this work? So this is what we have with our AC. With our direct current, since in this case, we're only going to use the positive part. You're going to do, or it's going to do half the weights, but together. And you guys may say, well, why would I want to change to AC? Because if we didn't change it, we would not be able to modify its frequency. Okay? So engineers, or long-term or a long time ago engineers noticed this. In the direct correct part, we are going to be able to change our pulse. And this is what we saw in university or a college course, our very famous PWM, which is the width of our pulsation. So if you remember correctly, these are AC. These are their pulse width. So this is going to start shutting off and powering on. And when this happens, when it's on, it's going to be 1. When we shut it off, it's going to be 0. Okay? So the bunch of these 1s and 0s, the longer a lamp or a light bulb is on, then that's going to be the pulse width, or it's going to make our pulse width a bit bigger. So when I press this, it's going to go down and it's going to stay there for as long as I need. However, do we change from our voltage to AC? Yes, we have to convert it to DC. Now, how do we do that? Thanks to diodes, we are only telling it to what our frequency is, or in this case, our frequency, for it to not go down. So I'm telling it, you know what? Just say it. Because its diode, its job is to direct the voltage towards one only spot or one point. So with our diodes, we are forcing our wave to become positive only. So once we go to our rectifying part, we go to this side. Now, on our filter part for our DC, that's when we have our capacitors. Now, what do capacitors do? Basically, all they do is they store its excess energy, or whatever energy that might be able to damage our drive. But basically, what we wish is a DC. Okay? So those peaks are going to start becoming regulated, as well as those dips, because in the end, that's the way that we're going to be able to get a straight line. So basically, thanks to its analyzing part and for its filter for the bus, BUS, then in that case, it's going to turn our conversation to direct. And then finally, once we have a bigger or a larger control, then we're also going to see that other investing part. So this is where it says tri-phased bridge part. So we're going to name this as the investor part. So this is where we can find our very famous IGBT. So these devices, we're going to place them as such, so that very quickly it is going to start. All depends on what we as users send out to comply as a visit she's going to start activating and deactivating everything that has to do with our different phases, so that way they can be they can do all these squares. Okay, so what we're going to do now, we're going to simulate Y for AC, which for direct current, if I hit, it's going to be completely with the alternate current. So thanks to this change from DC to AC, we are going to be able to control mostly our frequency. Now, why do I say that I like the way that our drives work? Because they're basically an internal simulation. Because in the end, we do get our wave, which is mostly what we had initially. However, thanks to our activations and deactivations for IGBT, we are able to simulate the most, or what we most can, our AC voltage. Okay, so that in the end, check this out, guys. In this diagram, what we want is to control our frequency. So we have our converter part, or the rectifying part. So we go in with our triphase part, and then from this we are going to get, thanks to that converting part, that rectifying part, we're going to get our half waves more continuously. So this is filtered, and this is what looks mostly like a line. So once we have this filtered, we are going to be able to command all of our half waves, but by pulse. And those pulse we are going to be able to simulate. We're going to be able to simulate anything that has to do with AC, alternate current. We're going to be able to play with our physical part, and we're going to be able to lie related to its motor, because it really does need an AC. But we are simulating AC because it's not real. Okay? Now, it's so close to reality that the motor actually doesn't care, doesn't mind. And it works with our drive output.
Okay. So this is how the frequency variator works.
Why frequency variator? Because VFD means variable frequency drive. Anything that we see here, like this, means this precisely. It's a drive. And this is basically how our variator works. Do you guys have any questions? Please let me know in the comments so that I can assess you, so I can help you out. Okay? So our drive really is, or really works as a mini computer. It's a controller, really. But it is a miniature PLC, which helps us simulate so that this is connected to the motor, and then we can modify our speed. Okay? What for? So that in the end we have a mechanical potency. Okay, we need to move this arrow to the end. So these are its characteristics. And now this is where we have our operator interface, or our display, so that we can control our parameters, etc., etc. Okay? So we're going to be running some drills, some exercises, so that you guys can see our drive, and all this makes sense. I'll see you guys in our next video. Big hug, guys.